Okay, welcome back. Let's continue the discussion about linear equations. See the second part. Solve equations that lead to linear equations. So linear equation ax plus b equal to 0. Ax plus b equal to 0. So this is linear equation. And some other equations at the beginning, they not like this. But after simplification, multiplication, you will eventually get ax plus b equal to 0. Then and we say that equation will lead us a linear equation. Okay? So see the example. So this part of example will require the modification, simplification stuff. Okay, so solve the equation. What equation? 2y plus 1 times y minus 1 is equal to y plus 5 times 2y minus 5. Okay, so clearly at this moment, this equation is never a linear equation. But let's try to do multiplication and simplify it. Okay, solution. The following will be our solution. There are two sides. They are products of two polynomials. So we're going to multiply them one by one. So you see, 2y times y is 2y squared. 2y times 1 is minus 2y. 1 times y is plus y. 1 times y is minus 1. This is left hand side. Right hand side, y times 2y, 2y squared. Y times 5 minus 5y. 5 times 2y plus 10y. 5 times 5 minus 25. See, so first you just do the multiplication. Multiply each part. And then let's see. You have 2y squared. 2y squared on two sides. They're balanced, so you cancel them directly. And negative 2y plus y is negative y minus 1 is equal to negative 5y plus 10y is 5y and minus 25. So at this moment, they are still in their original sides. This is left hand side, this is right hand side. Nothing changed. We only cancel two same terms from two sides. We can do that. And we combine like terms. They are called like terms. We combine like terms. Okay, and then I'm going to move one term to the other side and this number to the right side. We'll move it cross the equal sign. You change the sign. So it's negative y is here. 5y move to the left side, it becomes minus 5y. Minus 1 move to the right side becomes plus 1 and minus 25. Okay, I will try my best to write everything correct. I mean, if I have any mistake, just send me email. I will send it to all the students. Thank you in advance. Okay, so minus 1 minus 5y is minus 6y. 1 minus 25 is negative 24. So y is negative 24 over negative 6 is equal to 4. Am I right? Yes, so the solution set is 4. So y is equal to 4 is the answer. And this one, up to this part, after we cancel 2y squared, then this is a linear equation. Okay, so from this step, after you cancel the square term, this becomes a linear equation. All the steps are in our discussion range. Okay, so that's why we say this equation will lead us linear equations. Okay, so in this simplification part, we simply just multiply several parentheses and just cancel the same terms from two sides and get the linear equation. We can do multiplication. And the other example, let's see the next example. We're going to solve the equation 3 over x minus 2 is equal to 1 over x minus 1 plus 7 over x minus 1 times x minus 2. So in this equation, we are going to simplify the rational expressions. So here is just simple multiplication, but here is a rational expression. When you have such a rational expression, you always multiply two sides by the common denominator of two sides. You have to eliminate the denominator and try to move them up. Okay, so here the denominator x minus 2, here x minus 1, here's x minus 1 times x minus 2. So the common denominator will be this product. So we're going to multiply two sides by this product in order to eliminate the denominator. Remember, we are going to multiply two sides by x minus 1 times x minus 2. It's like what we did in the last video. If you have 1 over 3, 1 over 2, we're going to multiply it by 6 to transform the fractions into the integers. So we like integers more than fractions. Okay, x minus 1, x minus 2, we multiply two sides. When you multiply the left side by this product, x minus 2, x minus 2 canceled, so you will have 3 times x minus 1. This factor canceled with the denominator. And this product times 1 over x minus 1 factor canceled, so you have x minus 2. And third term, 7 over x minus 2 times x minus 2. The whole denominator is cancelled with this whole factor, whole product, so you get 7. Okay? So after multiplying two sides by x minus 2, we get a linear equation. This moment, this is linear equation. All right? Now let's try to simplify it. We're going to move x to the left side, all x to the left side, all numbers to the right side. So first, it's 3x minus 3. Here's x minus 2 plus 7. And then we're going to move x to the left side, negative 3 to the right side. You move to the left side, it becomes negative x. Negative 3 move to the right side becomes positive 3. And minus 2 plus 7. 3x minus x, 2x. 3 minus 2, 1. 1 plus 7, 8. And then x is equal to 4. Okay? So x is equal to 4. And whenever you have such thing in this part, you have fractions, you must verify it. Here, this is polynomial. For the polynomial function, you don't have to verify it, but for the rational function, you must verify it. You have to check if you really have the correct stuff. Okay? So check. Because sometimes it will give you the trouble. When x is equal to 4, the left side becomes a 3 over 4 minus 2. 3 over 2, this is left side. Okay? So x equal to 4, and you do 3 over 4 minus 2 is a 3 over 2. The right side, you will get 1 over 4 minus 1 plus 7 over 4 minus 1 times 4 minus 2. Well, let's check. 1 over 4 minus 1 is 1 over 3. 7 over 4 minus 1 is a 3. 4 minus 2 is 2. It's 1 over 3 plus 7 over 6. Okay? So 1 over 3 is a 2 over 6. 7 over 6. So it's a 9 over 6. 9 over 6 is a 3 over 2. It's the right side. So the left side and right side are equal. So the solution set is 4. It's correct. It's correct. Okay, this is correct. Okay, so this is verification step. Here is a computation step. And we do this problem by multiplying two sides by the common denominator of all the denominators, either from left side and from right side. Okay. And next, let's see why this checking step is important in this fraction problem. Solve the equation 3x over x minus 1 plus 2 is equal to 3 over x minus 1. Okay. Okay, now let's see. So the left side, the denominator x minus 1, right side, the denominator x minus 1. So the common denominator, multiply two sides by x minus 1, we just need one factor, that's enough. It will cover all the denominators. So let's check. So you multiply two sides by x minus 1. This term, x minus 1 cancel, so you only have the numerator, 3x. Right side, 2 times x minus 1, nothing is cancelled, so it's 2 times x minus 1. On right side, 3 over x minus 1 times x minus 1, the denominator is cancelled. Okay, so that's a linear equation. This is a linear equation we are interested. And then let's simplify it. 3x plus 2x minus 2. 3x plus 2x, 5x. Move 2 to the other side, it's 3 plus 2 is equal to 5. So 5x is equal to 5, then x is equal to 1. If we only, cover this multiplication step, if we only have this part, if we just have this linear equation part, the whole steps are totally correct. But this is correct only for the linear equation. We need to look for the solution of the original equation. Let's go back and check it. Check step. X is equal to 1. The left side, you will see, where is the left side? 3 times 1 over 1 minus 1 plus 2. Well, we have problem. The denominator, 1 minus 1 is 0, is undefined. Zero denominator. So left side is undefined. Once you get left side is undefined, the rest of the checking step, you don't have to do it because this is not the solution. Okay? This is not the solution. Let me get my, oops. So you see here, when you have a rational expression or rational equations, even though you get the linear equation after simplification, but still your solution may not be your original equation. It is a solution of this linear equation, but it's not a solution of original. Why we have such a problem? The problem comes from this multiplication. We multiply two sides by x minus 1. Remember that. We can only multiply an equation by a non-zero term. You cannot multiply equation by 0 because if you have 0, for example, this one is definitely wrong, but if you multiply two sides by 0, it is correct. Right? So the contradiction comes from this multiplication. It doesn't matter the original equation is correct or incorrect. After you multiply two sides by 0, it's always correct. So this is one of the requirements. We can only multiply equation by a non-zero term. And here you multiply the equation by x minus 1. So when we multiply the equation by x minus 1, we actually assume that x minus 1 is not equal to 0. Even though we didn't mention it, but we actually assume this x minus 1 is not equal to 0. Equivalently, x is not equal to 1. X can never be 1. If x is equal to 1, you multiply this factor becomes 0, so you multiply the equation by 0. That is not allowed in our computation step. And that's why this 1 can never be the answer. Okay? And for the previous part, the previous problem, we get a 4. This is the answer because when x is equal to 4, remember we multiply two sides by x minus 1 times x minus 2. When x is 4, this factor, this product is not equal to 0. So that's good. That's allowed. Okay? But here, this is not correct. So the equation, we will say it's not solution. The equation has no solution. The solution set, if it has no solution, the solution set is empty, is an empty set. So it's empty set. Okay? So that gives us a alert. Whenever you have a rational function, rational equation, you're solving it, you multiply two sides by some expressions, you must verify if your answer is the answer of the original equation. You must do it. It's very, very important. Okay? Well, this is an argument. This is an argument or explanation why it is this situation happens. It's not the answer. Answers here. Once you verify this is undefined, you just say the solution set is empty. That's it. You don't have to do the whatever analysis in the exam. In the exam is not. This is not the solution. Here's the solution. Up to this step. Okay. So what is the solution? So multiply. Well, you don't have to write this sentence. You just keep this in mind. What you do in this step. You multiply two sides by this number, by this expression. You get this. You get x equal to 1, and you verify the left side is undefined. This part you don't have to write. And then you say this is not the solution. The solution set is empty, and that's it. Okay. Try to repeat it. You have this part. You check. Left side is undefined. It's not solution. Solution set is empty. Okay? That's an equation without solution. And now let's see some word problems. Try to get a word problem. I'm not trying to copy it. It's very long. It's a word problem. Let's see. Okay, it's example 7. Example 7. I hope you can read it. Example 7. Converting to Fahrenheit from Celsius. Okay, so in the United States, we measure temperature in both degrees Fahrenheit with the circle F and degrees Celsius with the circle C, which are related by the formula. Okay, which means those 2 degrees. C is equal to 5 over 9 times F minus 32. What are the Fahrenheit temperatures corresponding to Celsius temperatures of 0 degree, 10 degree, 20 degree, and 30 degree Celsius? Okay, so this is the question, converting to Fahrenheit from Celsius. Okay, so keep this in your mind, and the formula, especially the formula, I will copy this formula. C is equal to 5 over 9 times F minus 32. Okay. Example 7 on page, what is the page number? Oops, page 87. Okay, so Celsius is equal to 5 over 9 times F minus 32. But the question is, what is F degree for C degree 0, 10, 20, and 30? Okay, so we know C is 0, 10, 20, 30. We want to look for the Fahrenheit degree. So here we get F, we plug in the formula, we get C. So basically we want to get the reverse formula. Reverse formula. Okay, so for this one, we're going to multiply two sides by 9 over 5. We multiply the reciprocal of this coefficient to cancel this coefficient. Okay, so to cancel the coefficient, 9 over 5. And then we're going to move this to the other side, negative 32 to the left side. It becomes plus 32. And then we are going to exchange two sides. It's not a movement, it's exchange. Okay, so this is a formula for the relation between F and C when you consider C as an input. This is a formula when you consider F as input. You have F, you can find the C. And this is a formula when you have C, you can find F. So the formula between the Fahrenheit degree and the Celsius degrees is that F degree is equal to 9 over 5 times C plus 32. The whole operation is multiplication by the reciprocal of the coefficient, and move this negative 32 from right side to the left side. It becomes positive 32, and then exchange two sides. Remember, exchange means A is equal to B, then B is equal to A. Symmetry. Okay, so we are going to keep this in mind. Then what is the answer? When C is 0, zero times 9 over 5 is 0 plus 32. It's a 32F, 32C. When C is 10 degrees, 10 times 5 over 2 is, you cancel 5, 10 times 2 is, where is 5 over 2? So 9 over 5 times 10 plus 32. So it's 9 times 2 is 18 plus 32 is 50 degrees. 9 over 5 times 20 and plus 32. 25 is cancel 5, you get 4. 9 times 4 is 36 plus 32 is 68 degrees. F is 9 over 5 times 30. Cancel 5, you get 6. 6 times 9 is 54 plus 32 is 86 degrees. Okay, so those are the answers. When the Celsius degree is 0, then the Fahrenheit degree is 32. When the Celsius degree is 10, the Fahrenheit degree is 50. When the Celsius degree is 20, the Fahrenheit degree is 68. When the Celsius degree is 30, the Fahrenheit degree is 86. It's 86. That's the answer of the example 7. Okay, so the example 7 just asks us to transform from one linear equation to another linear equation. You consider C as a function of f, or you consider f as a function of c. Which one is input? Which one is output? Right? So that's our second part, the linear equation, or the equation that will lead us linear equations. Okay. The third part, solve problems that can be modeled by linear equations. Can be modeled by linear equations. Okay, so let's see. This is short. Let me copy it. Example, a total of 18,000 is invested. Some in stocks and some in bonds. If the amount invested in bonds is half that invested in stocks, how much is invested in each category? Okay, so how can we divide the total investment into two parts? Okay, so solution. Okay, so remember that the total amount is $18,000. You have to divide it into two parts. If one part is known, the other part is known. For example, if you divide 8,000 to the stocks, then 18 minus 8 will give you the investment in the bonds. Okay, so we only need to set one quantity and use subtraction to get the other quantity. So let X be the amount invested in stocks. Okay, then 18,000 minus X is invested in bonds. That's the division into categories. That's the first condition. That's total. We use this total to get this relation. Okay, and second, we see the second condition. If the amount invested in bonds, where's the investment bond? Here. This is total invested in bond is equal half that invested in stocks. Invested in stocks is X. The amount invested in bonds is half that invested in stocks. That is the quantitative relation, quantity relation, right? And we're looking for X, and this is what? This is a linear equation, right? So how do we get it? How do we solve it? We move X to the other side. It's 18,000 is equal to half X, and you move it to the right side, it becomes plus X. Half X plus X is 3 halves X. And we exchange two sides. We'll get 3 halves. X is equal to 18,000. So X is equal to 18,000 times 2/3 times reciprocal of the coefficient. Reciprocal, you always flip it because you do the multiplication on two sides. You want to cancel this 3 halves. Okay, so cancel 3, you get 6,000. 18,000 cancel with the 3, you get 6,000 times 2 is 12,000. Okay, X is 12,000. X is 12,000. Then the 18,000 minus 12,000 is 6,000. Okay, so remember, this is a word problem. You are going to answer the word problem. This is an equation that's slightly different, even though they are related, but slightly different. So the final step, you have to answer it. So the 12,000 is invested. This is X. Where is X? X is stock. In stocks. 6,000 is invested in bonds. Okay, so that's a final answer. If it is a word problem, you cannot just leave those quantities as the answer. They are meaningless. You have to use words to explain the meaning of each quantity. Okay, so that is a complete answer. That is a complete answer. Right? Okay, very good. Next. Let's copy the other one. The next problem. Next problem is short. So Shannon grossed $435 a week by working 52 hours. Okay, 52 hours. Her employer pays her time and a half for all hours worked in excess analysis of 40 hours. Okay, this is a setting. With this information, can you determine Shannon's regular hourly wage? Okay, so it's a very practical problem. Okay, what is a time and a half? So for example, if your regular hourly wage is $10 per hour, time and a half means you have $10 and then you have half of $10, 5. So time and a half, it means $15 per hour. Okay, so that is the meaning of a time and a half. 1.5 times of a hourly wage. Okay, so I mean, of course, you have to work after 40 hours. You can get such promotion. Compensation, not promotion. Okay, so we want to look for Shannon's regular hour wage. So let X be Shannon's regular hour wage. This X means within 40 hours, she can earn X dollars per hour. Okay, so in other words, in the first 40 hours, each hour, Shannon, in the first 40 hours, Shannon gets X dollars per hour, right? X dollars per hour. So in total, she gets 40X dollars. She gets $40, 40X dollars. She gets 40X dollars. Now after 40 hours, so you see here, totally she works 52 hours. After 40 hours, her wage is a time and a half, so it's a 1.5x per hour, right? Time and a half, 0.5. And she worked 52 minus 40, 12 hours. So she got 12 times 1.5x dollars. 12 times 1.5, what is it? It's a 12, oh, okay. Let's compute 12 times 1.5, 18x. So she got 18x dollars. So total, she got 435 1 week. So we get 40x plus 52 minus 40 times 1.5x, right? So we just try to get, how do we get 12? 12 is 52 minus 40, so that's why I don't directly copy 12, because 12 is not provided directly. So you copy 52 minus 40 and times 1.5. 1.5 is time and a half, that's the given. The total is 435. Okay, so this is the equation you should clearly write down in the exam. This, all the words are not necessary in the exam, but this equation is clearly enough or is very important for me to give you credits. Okay, so after that, let's try to solve it. This is a 40, it's a 12 times 1.5, it's 18, so it's a 40x plus 18x is 435, it's 58x is 435, so x is 435 over 50, 58 over 58. You just compute it. 7 times 8, 56, 5, 41, 35 plus 5 is 41, so it's a 9, 2, 0, so point, 5, 50, 20, okay, exactly, so x is 7.5, $7.50 per hour. Okay, so this is the solution of a linear equation. You have to answer the question. So Shannon earns regularly $75 per hour. This is your answer, clear answer for the word problem. Her hourly wage is $7.5. $7.5. Okay, so we finished the first section of the linear equations. So we're going to stop the video at this moment. We'll continue the discussion in the next video for the second part of the lecture. The lecture is not done. The video is done for the linear equations. So in the next part, we're going to study the quadratic equations. Okay? So continue the study and by watching the next video. Thank you.